In the academic world, learning design is a pristine, controlled environment. You have the time and resources to build the perfect lesson. Then you step into the corporate workplace. Suddenly, you're hit with flashing deadlines, chaotic demands, and immediate pressure to produce. Leadership hands you a mandate. They want a training program that improves productivity and product quality. The catch? You have a shoestring budget and a launch date next Tuesday. In theory, you balance three core variables: your audience, the content, and the desired outcome. But in reality, a heavy, rigid constraint called budget and time clamps down, squeezing your options into a tiny sliver of what's actually possible. The temptation here is the cheap compromise. You take basic, uninspired content and slap a gamified wrapper or a slick technological interface over it. It checks the innovation box for stakeholders, but it leaves learner behavior unchanged. ID mastery means engineering the most effective compromise for your specific situation, based entirely on where your learners experience friction. To defend these trade-offs to leadership and secure the necessary budget or time, use deep audience analysis. Prove exactly why a specific demographic requires a specific approach. Consider adult learners forced to retake mandatory high school math exams. These students carry significant academic trauma and approach the material with high anxiety. The standard, scalable approach here is procedural fluency, lecturing rules and assigning mass practice. For this demographic, that method actively harms them. It overloads their working memory and triggers their anxiety, reinforcing their past failures. This diagram shows the Lesh translation model. To bypass that anxiety, the ID must shift away from abstract rules and present the math through multiple interconnected representations, moving between physical manipulatives, real-life situations, pictures, and written symbols. This flowchart outlines a technology-driven adaptive system acting as a personal tutor. It evaluates gaps and feeds interleaved practice questions. When a learner fails, the system provides progressive hints, absorbing the failure, lowering cognitive load, and gently guiding them back. This image displays how that low-pressure approach is executed in the actual interface. The learner engages with visual manipulatives, like shading a grid, rather than staring down a wall of algebra. The trade-off here is steep but necessary. You sacrifice upfront technology budget and design time to buy the efficacy required to reach anxious, non-traditional learners. Now look at a completely different audience. College students, enamored by the utopian glamour of becoming young startup founders. Standard instructional design solutions like motivational lectures or reading assignments fail here. These students already possess abundant motivation. What they lack is a reality check on the grind of actual entrepreneurship. You must pivot to a task-based, experiential strategy. Theoretical concepts aren't just lectured, they are dovetailed directly into mandatory, real-world business deliverables that the students must execute to survive the simulation. Abstract concepts like regulatory compliance and market segmentation are forced into tangible weekly outputs. By week 3, they aren't just reading about laws, they are physically locating and downloading the correct compliance forms. Because these outputs are complex and high stakes, passive facilitation is abandoned. Instead, students are assigned hands-on mentors to actively guide them through the weeds of building financial and marketing plans. The trade-off is clear. You abandon fast delivery and broad scale, trading hours for weeks and demanding intense mentor resources. It is expensive and slow, but it creates authentic behavioral change. Transitioning to the corporate sector, you will frequently face pressure to use cutting-edge technology. A common demand right now is using virtual reality to train employees on rapidly evolving fields like artificial intelligence. Pedagogically, the logic is sound. VR offers unparalleled immersion and can generate massive engagement for complex technical skills. This chart illustrates the business flaw. Initial VR build costs are high. Because AI evolves rapidly, content quickly outdates, causing recurring update costs to exceed training value. The pragmatic pivot abandons immersion for simple, modular content blocks that experts can cheaply swap out. Sometimes you must actively reject the most engaging medium available. If the content's lifespan is short, investing in highly produced media is a poor business decision. Finally, consider a scenario with extreme contextual friction. Teaching abstract corporate financial planning to rural adult women with minimal formal education. The The cognitive barrier here stems from a total absence of context. Standard corporate modules fail because the financial concepts are too far removed from their daily operations. To solve this, you leverage the earthy wisdom they already possess. You implement a story-based approach to move them from their familiar ecosystem into these completely unfamiliar financial concepts. You create a relatable fictional world using character archetypes, a constantly worried potter, a cynical farmer. Every module begins with one of these characters facing a relatable daily need, which is then solved by introducing a specific financial product. But a digital story alone won't stick. You have to build a physical bridge. The learning process must culminate in a real-world, mentored task physically executed within their actual community. To complete the module, the learner must successfully fill out an application to open a real bank account at their local institution. You are trading fast, cheap deployment for a massive increase in upfront ethnographic research and localized mentor coordination. That heavy initial investment is the only way to guarantee the training is actually relevant. This matrix plots our 4 scenarios against audience friction and logistical investment. Effectiveness is entirely relevant to the specific friction you are trying to solve. What works perfectly in one quadrant is disastrous in another. You can use this exact logic to evaluate requests and push back when stakeholders demand flashy but inappropriate educational trends. Rule 1. If the content is highly volatile, reject high-cost immersive media. Optimize for modularity and cheap, rapid updates. Rule 2. If learner anxiety is high and the subject is rigid, reject cheap, scalable lectures. Fight for the budget to build adaptive tech that acts as a patient, personal tutor. Rule 3. If the audience lacks context or holds utopian illusions, reject abstract theory. Force experiential, task-based reality checks that demand actual deliverables. The most effective instructional designers identify specific learner friction and apply the pragmatism required to execute a balanced compromise.